Hello guys, so today we are going to discuss this problem, course schedule. This is another problem of a topological sort in a graph. So we are trying to find out a cycle in a directed graph in this course schedule, and that is we do with the topological sort. So I have also created an earlier video on topological sort if you want to see. Um, that's in the playlist, you can go through it. So let's understand this problem. It says that there are total of number of courses which you can take labeled from 0 to number of courses minus 1, and you are given an array prerequisites in which the A and B are given AI BI, which indicates that the course B is first you want to take before course A. Okay, for example 0 1, so here A will be 0, 1 will A will be 0, 1 will be B. So you indicates that you take course 0, that to take course 0 you have to take course 1. Okay, so 1 has to be taken before course 0. Okay, so let's try to understand it better. And the question says is that we have to return true if we can finish all the courses, otherwise we have to return false. Okay, let's understand this better. So let's suppose um, we have a course we have array something as 1 0, then we have 2 1, then we have 3 2, then we have 5 4, then we have 6 5. Right, so what this array means, so here we have, we know we have A, this is A, and this is B. So B has to be completed first before completing A. So there will be a edge from B to A. So that means what? We'll have a graph where we'll have 0 and we'll have a edge to 1, something like this, right? Because first we have to complete B, that is 0, then we have to complete A, that is 1. So similarly, if we have 2 1, it means there is a edge from 1 to 2. Is there a better drawing? Okay, let me take this. Then we have a edge from 2 to 3 in this example. Let me take 2 to 3, right? And then we have a edge from 4 to 5. So we have a node 4 and we have a node 5, because this is 4 is B, so we are making from B to A. And then we have no from 6 5 to 6. So from above input we get this kind of graph. This is, in this graph we do not have any cycle, but if we introduce something like this here, we get 4 6, right? So there will be a node from 6 to 4. Okay, that is, in this case 4 6, this will become A and this will become B. So in order to complete A, that is course 4, we have to complete 6. So now this is the cycle here. And what does this mean? That we have a course 5. So in order to complete course 5, we have to complete course 4 first. In order to complete course 6, we have to complete 5 first. And in order to complete 4, we have to complete 6. So this is a contradiction, right? Because let's suppose we have this course which we have to complete first, and this also we have to complete first. In order to complete 6, we have to complete 4, and in order to complete 4, we have to complete 6. So this is a contradiction, and we'll return false in this case, right? So again, what we are going to do is we are going to create, as we do in the topological sort, we are going to create an array of incoming nodes. So in array of incoming nodes, we, for node 0 there is no incoming node, then For node 1, there is one incoming node which is 0. For node 2, there is one incoming node which is node 1. For node 3, there is one incoming node which is node 2. For node 4, there is one incoming node which is node 6. Then for node 5, there is one incoming node 4, that is the incoming edge. Then for node 6, there is one incoming edge, that is node 5. And then we'll also create a out degree. So out degree means the number of the outgoing edges from the node. So for node 0, we'll have out degree 1. For node 1, 1. For node 2, we have 1. For node 3, which this is 0. For node 4, 1. Node 5, 1. Node 6, 1. Right? Let me mention it, and let me also mention it here. So now what we'll do, we will look into the out degree. Then we'll find whichever node which has a out degree as 0. In this case, this is 3. So we'll take it in a queue. So we have a queue, and we'll take it in queue. We have node 3. So the purpose of this is that whatever nodes which are not having a out degree, we'll remove those from the graph. So here we'll take it 3, we'll pop the queue. So on pop, we'll get node is equal to 3. And then what we'll do, we will find all the incoming edges to 3. Find all nodes having incoming edge to 3, right? So there is only one node which has incoming edge to 3, which is 2. So if we are excluding this, so this edge which is coming from 2 to 3 will be reduced, that is, it will become 0. So we'll go to the out degree of 2, and we will make it as 0, right? Then we this out degree has become 0, so we'll push it on the queue. So now our queue is 2. We'll pop the top of the queue, so the node will be 2, and similarly we'll find all the incoming edges which are coming to 2. So here in this case, we remove this, then this node has out degree 0, we remove this, and we remove this as well, right? So now we see that we are left with a graph which has a cycle, and if this graph was not having a cycle, then what will happen? Let us just check. So let's, for example, let's suppose this graph is not having a cycle, right? So in this case, this node 6 is not having any out degree. So in that case, this must be in a queue, right? Because we are taking all, then it will have out degree as something as this, right? 3 has out degree 0 and 6 has out degree 0. So we'll push 3 and 6. So in that case, after reducing all this, we'll come to node 6 here, and we'll pop the node 6, and then we'll remove the node 6 from the graph. We will remove the incoming edge or the out degree of 5 by 1. That then we'll push 5 to the queue. We'll remove the out degree of 5, in degree of 5, that is out degree of 4, and finally we'll remove this. So the size or all the elements of the out degree finally will become 0. And if that is the case, then our graph is not having a cycle, otherwise it has a cycle. Let's see into the code now. So what happens? First of all, we are creating the incoming node graph, incoming nodes graph and out degree. So we have taken incoming node as a two-dimensional vector, and we have taken out degree which is equal to number of courses and initialized to 0. Then we are traversing this array. Let's suppose our array is this, right? So what we'll do is we know that in the incoming array, this will be always A, this will be B, and we have to create a edge from B to A. So prerequisites of 0 is always A, prerequisite of 1, that is this one, in this entry will always be B, and we have to create a edge from B to A. So in this case, incoming node for A will be B, right? And out degree of B will be incremented, right? So I think this is very clear. Now we will push all the nodes in the queue which has out degree 0. So we traverse out degree and we push it in the node, right? Okay, let me take it is, this is incoming node. Let me take this. Okay. So now until queue is not empty, so initially we will have entry as 3 in the queue. So this is our incoming incoming graph. So what we'll do is we'll go to the incoming node of the node which we have in the queue. So that was 3. So we got that to the node 3. There is one incoming node, incoming edge which comes from 2. So what we'll do is we'll go to the out degree of 2, right? And we'll reduce it by 1, and if out degree becomes 0 we will push this node, that is 2, into the queue, and we'll keep on doing it, and in the end we'll just traverse the out degree. If any out degree is greater than 1, then we'll return false. If all the out degrees are 0, then we'll return true, right? So that's the solution, and this solution is pretty faster. It was 91% faster than the other solutions. So the time complexity for this algorithm is OV plus E. The topological sort has the time complexity of vertices plus edges. And that's all for the video. Thanks a lot. Have a good day.